Hi, today's lesson is lesson 3.2, and we're going to be talking about absolute value again and opposites, but this time with rational numbers instead of integers. So let's get started. I'll share my screen with you. Okay, so 3.2 is our lesson, and it is opposites and absolute value of rational numbers. And our standards or our objectives today are I can find the opposite of a rational number. I can write the absolute value of a rational number. And it's standard 6NS6C. We'll be talking about finding the position, I should say integers. Find and position integers and other rational numbers on a horizontal or vertical number line diagram. Find and position pairs of integers and other rational numbers on a coordinate plane. The coordinate plane part will come later. We are going to work on just the number lines today. So here's a number line. You should be pretty familiar with the number line by now. We know what the integers are, right? The integers are the whole numbers and the negative whole numbers, right? They are not the in-between numbers, but now we're going to be talking about rational numbers. So positive numbers, we talk about our graph to the right of 0, and negative numbers are graph to the left of 0. And I'm going to actually close myself out so you can see the whole screen here. Okay, and myself up there, keep going. Integers are only the whole numbers on the number line, right? So we've talked about integers, we've done a whole unit on that. So there's some integers. You could say -3 is an integer, -4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. They're all integers. However, rational numbers are the in-between numbers on the number line. So now we're going to be talking about the in-between numbers. And there's lots and lots and lots and lots of in-between numbers. You have negative rational numbers and you have positive rational numbers. They are the in-between numbers. Here's our number line again. So let's graph -3.5 on the number line, -3.5. Where would that be? So do you think -3.5 would be here or would it be here? Right, the numbers are going to go 1, -1, -1.5, -2, -2.5, -3, -3.5, -4, -4.5, and -3.5 is -3.5. So we are going to put it, we have to make sure with negatives we go past the integers. We're going past the -3. And that's where it would be. So if you said that, you guessed correctly. Yay. Now we're going to graph 1.25 on the number line. So would 1.25 be here, somewhere in here, or somewhere in here? What do you think? Well, 1.25 isn't quite halfway between the number, right? So be sure you're going past the integer. The integer is the 1 part. Be sure to go past the 1 part. How much past do we go? We go enough past it to be a quarter past it, because 0.25, think of quarters. 25 cents is a quarter. It's 1/4 of a dollar. So 0.25 is 1/4 of the way to the next integer. So you're at 1, you're 1/4 of the way to 2. So this is half of the way, that's 0.5. This is 3/4 of the way, or 0.75, thinking of quarters, 25 cents, 50 cents, 75 cents, right? And when you get to 2, you've gone the whole way. So 1.25 is going to be about right there. So let's see if our arrow pops up here. There it is. There is 1.25. Make sure whether it's negative or whether it's positive, you go past the integer, On the -3.5, we went past the -3, the integer part. On 1.25, we went past the 1, the integer part. You can graph the opposites of rational numbers the same way you found the opposites of integers. So how do we do that? Well, two rational numbers are opposites if They are the same distance from 0, but on different sides of 0. So we should know pretty good about opposites at this point. So negative 2 3/4, that's about 3/4 of the way to the next number. We went past the negative 2. The opposite of negative 2 3/4 is positive 2 3/4. Notice how we went past the 2, 3/4 of the way. Okay. And notice how negative 2 3/4 is the same distance from 0 as 2 3/4 is from 0, just on opposite sides of 0. So I could draw a little line here, straight down, and say that this distance, let me get an arrow here, from this distance from here to here is the same as this distance from here to here. They're opposites. That's the definition of an opposite. The value of a stock changed $1.05 of a dollar on Tuesday, 1 5/8 of a dollar. The stock's value changed negative 4 1/4 on Wednesday. Find the change in stock value from Tuesday to Wednesday. I'm going to use a number line to help me. So I'm going to use a vertical number line. You can use a horizontal number line. They will go either way, right? And I'm first going to graph my 1 5/8. So I'm going to go past the 1, and 5/8 is a little past halfway. So it's going to be somewhere in here, not quite half, but a little bit past it. So right over here. So that's 1 5/8. The stock value changed to negative 4 1/4 on Wednesday. So I'm going to find that spot. So negative 4 1/4 is past the negative 4, and 1/4 is a quarter, right? So a little bit, 1/4 of the way to the number 5, the negative 5. So now I have to find the change from this point here. I'll put a little dot there just so we can see that point. Find the change from this point here to this point here. How do I figure out how much of a change that is? How do I figure that out? Well, it's easy with integers, right? You just add the units up. But now you got some quarters in there and an eighth in there. So this is what you have to do. You have to add them up. Now, you cannot add them up the way that they are, because with a fraction, the bottom number has to be the same before you can add them. And we have a denominator of 8 and a denominator of 4. So right here is 8 and right here is 4, and we can't add those the way they are. So we are going to have to change the bottom numbers. So I know that 4 will go into 8. So I'm going to leave 5/8 just the way it is. I don't have to change that one, but I do have to change 1/4. So where did I get 2/8 from? Well, what I did is I said in my head, I know I got to make it an 8. So 4 times what gave me an 8? 4 times 2, right? Gave me an 8. That's how I got my 8. So if I times by 2 on the bottom number, I have to times by the same number on the top. So I have to times by 2 on the top. So 1 times 2, that's where I got my 2. Now I can add because I have 8s on the bottom, and now I can add. And remember, when you're adding fractions, you never add the bottom numbers. You only add the numerators, the top numbers. So you're only adding the 5 plus the 2. So let's see if our computer will do this for us. There it is. 5 plus 2. 5 plus 2 is equal to 7. That's where our 7 comes. And we never add the bottom numbers. We just keep it in 8. So the bottom number stays in 8. But now we also have to add what? Our whole numbers over here, our 1 and our 4, right? We can't forget about those. So we have to add that as well. Oops. Did I not put it in there? I forgot to put it in there. So 4 plus 1 is 5. I forgot. So let's put it in there. Let's change it to red. Can I do red? Yeah. So it's really a change of 5 7/8. See how easy it is to forget about those whole numbers over there? So yes, so it's good that I made that mistake so that you don't make the same one. So then we've got to change, what is this? Graph, oh, so now we have to graph the opposite of the change. So graph the change on the number line. So they're saying graph 5 7/8. So that is not in the right spot. So never mind that. But graph the opposite. Ignore that because this is 7/8. It doesn't know about the 5. So just ignore those dots. So if I was to graph 5 7/8, that would be up here somewhere. I was graph the opposite. -5 7/8 is down here somewhere. So that's where you should be looking. Ignore these. X those off. Those are wrong. Those are only 7/8 of -7/8. Okay, I'm going to clear this and go on from there. Okay, now we're back to the horizontal number line. So we have number and the opposite. So we're going to graph each number and its opposite. So -3.8. That's -3 8/10. So it's like dividing each little section. So it's like dividing this -3 and this -2 into 10 teeny tiny little sections here. If I was to go, I can't probably do it because it's too small of an area, but I would divide it into 10 teeny tiny little sections. I won't get 10 in there because it's too small, but think about it in your head that way. So -3.8, where is that going to be? Well, I'm going to have to go past the -3, 8 units out of the 10. So about there would probably be about -3.8. What's the opposite of -3.8? Well, it's the number that's 3.8 units to the right of 0. So we're going to have to go past the 3. There it is, 3.8. So it's the same distance from 0 as -3.8, just on the opposite side. They're opposites. Yay! And if you put a little line in between the center here, you'll see that they are the same distance from 0, just opposite sides. Next one, -1.25. We're going to graph that. So you could pause the video and you could try to find that first before I tell you, and then see if you can get it right. So -1.25, we're going to go past the -1. 0.25 is 1/4 of the way. So that one I could actually draw those little lines in there because I only have to have 4 of them instead of 10 this time. This is about half. And then I need another one, right? So where would -1 and 0.25 be? It'd be right here on the first line, right? This is -1.25. This is -1.5. This is -1.75. So hopefully our dot will end up about where we put our lines. Yep, -1.25. So what's the opposite now? +1.25. So you're going to go past the 1 1/4 of the way. So again, we could draw our little lines. So we could draw one here, we could draw the 1.5 there, and then this would be 1.75. So then our dot should end up on our 1.25 line. And there it is. So those are opposites. And notice how they're the same distance from 0, just on opposite sides. It's doing weird things. Okay, now we have 2 1/3. I'm trying to get rid of that 1.25. I don't think it disappeared. So the opposite of 2 1/3 is -2 1/3. So there, now it appeared. Okay, so -2 1/3 is going to be where? Past the -2, 1/3 of the way, just like this one here. So you can probably draw thirds. So this is 1/3, this is 2/3, and then 3/3 is the whole way, right? Or we're going to have to go past the -2. So we're going to draw on this one here and here. It's not exact, but that should be 1/3, 2/3, 3/3, or -2 1/3, negative 2 and 2/3, negative 3. So let's see where that ends up. See if we have it in about the right spot. Yep, about negative 1 and 1/3. I mean negative 2 and 1/3. Okay, hopefully our numbers will disappear after this. Those are the opposites. See what happens. Oh, now it's your turn to give it a try. See you back in a moment. Welcome back. Let us continue. Now we're going to talk a little bit about absolute value of rational numbers. Remember, absolute value is a distance from 0. So absolute value is always positive because distance can only be positive. It doesn't make sense to measure one point to another point and call it a negative distance, right? That does not make sense. So absolute value is a distance. It's always positive. You can find the absolute value of a rational number the same way you found the absolute value of an integer. The absolute value of a rational number is the number's, what did I say? Distance from 0 on the number line. It doesn't matter which side of 0 the number is on, absolute value is always a positive distance from 0. Always and forever a positive distance from 0. So negative 3 1/2. How far away is negative 3 1/2 from 0? Well, how many units is it from 0? 3 1/2 units from 0, right? So the absolute value of negative 3 1/2 is equal to 3 1/2 units. Okay, don't get mixed up with that. The absolute value of negative 3 1/2 is 3 1/2. It's a positive value. Okay, I'm going to clear my drawings. Here's an up and down number line. The table shows the average low temperatures in January. Where's the table? There it is. The table shows the average low temperatures in January in one location during a 2-year span. Find the absolute value of the average January low temperature in 2009. So which temperature are we going to be looking at? The average low temperature in 2009. Okay. So that's the number we're going to be looking at. So let's graph that. I'm graphing. What am I graphing? I'm graphing negative 3.2. The average January low temperature. I did 2008. So let me clear this. I actually did. Let's cross that off. Average January low temperature in 2008. Mrs. Claus, what are you typing on this document? Okay, so we're finding the average January low temperature in 2008. So I'm looking for this number. Okay, negative 3.2. And so here it is, graphed negative 3.2. I went past negative 3, 2/10 of the way. 0.2 is divided into tenths now. And then I have to see how far away it is from 0. It is 3.2 units away from 0. That's a positive distance. So the absolute value of negative 3.2 is equal to positive 3.2. The absolute value of negative 3.2 is positive 3.2. Okay, now let's just take it like this. What's the absolute value of negative 4.5? Do you know? Did you say positive 4.5? Then you are correct. Very good. What's the absolute value of 1 1/2? Did you say positive 1 1/2? Then you are correct. What's the absolute value of negative 3 1/4? How many units is negative 3 1/4 from 0? Did you say positive 3 1/4 units? Then you are correct. Some kids get messed up. So they might see, for instance, this one here and say, oh, the absolute value of positive 1.5 is negative 1.5, but that is incorrect. Absolute value is always a positive distance from 0. So get that clear in your mind so you don't make that mistake. The absolute value of a rational number is always positive, even if the number in the brackets here is positive. And this guy says absolute value be like this. Yeah, 2 brackets, right? 2 lines on either side. Me, I'm sad, them. Then turn it into something positive, me. And then he put I'm sad in the absolute value signs. So it becomes positive, right? Okay. Now it's your turn to try some absolute value numbers. See you back in a moment. Great, welcome back. We are now on analyzing rational number positions. So think about this. Is negative 6.85 to the left or to the right of negative 6.8 on a number line? Negative 6.85, is it to the left or to the right of negative 6.8? Well, you should try to find those on the number line. So let's do that. Negative 6.85, we're going to go past the negative 6. Negative 6.5 would be right in the center. So negative 6.85 is probably going to be somewhere over here. Negative 6.8 isn't quite as far, is it? It's right next to it, but not quite as far. So negative 6.85, this is negative 6.85, farther away one, is farther away than negative 6.8. This one here is negative 6.8. So it's going to be to the left of negative 6.8. Oh, and there's my decimal point. There's negative 6.8 and there's negative 6.85. I mean, it's not exactly right because I had a little bit of space only to work in. Is negative 4 3/4 to the left or to the right of negative 4 1/4 on the number line? So we can try that right here. Negative 4 3/4. Now we can put this right here. So we have 1/4. Let me get a line here. We have 1/4, negative 4 1/4. Oh, but wait a minute. These go by 2s. Let me clear that. So the center line here is really negative 5. So you got to look at your scale on your number line. So this is really negative 5. So I'd have to be able to divide this section up here into 4 little pieces. And I don't think I can do that on the computer, but we can kind of get a general idea of where it would be. So negative 4 3/4 is going to be to the left of negative 4 1/4. So I think it is going to try to put some points in there for us. So let's see. So that's kind of about negative 4 3/4. It's kind of hard to show it on this tiny space, and there's negative 4 1/4. It's going to be negative 4 3/4 is going to be farther to the left than negative 4 1/4 because negative 4 3/4 is a smaller number. Remember, as numbers go left of 0, they get smaller the bigger they are, the farther from 0 they are. They're bigger the closer to 0 they are. Is 7 2/3 to the left or to the right of 7 1/3? Now this is a positive one, right? So it's to the right because 7 2/3 is more than 7 1/3. So 7 2/3 is going to be farther to the right. So should be putting it in there. There's about 7 1/3 and there's 7 2/3. So it works just the opposite on the right side of 0. The numbers get bigger as you go farther away from 0. Okay. And continue to analyze some positions. If the absolute value of a negative number is 2.78, what is the distance on the number line between the number and its absolute value? What is that question asking us? If the absolute value of a negative number, okay, some negative number here, negative question mark, the absolute value of it is equal to 2.78. What does that mean that the number inside the parentheses has to be? It already told us it was negative, so it has to be 2.75, the question mark, right? In order to get 2.75 as an answer, so it has to be negative 2.75. So let's stick that in there. Negative 2.78, not 75. Negative 2.78, right? That's true. What is the distance on the number line between the number and its absolute value? Well, the number we decided was negative 2.78, somewhere over here, a little bit past half. And then 2.78 is somewhere over here, a little bit past half. So what is the distance? I have a feeling that's going to pop up when I click on this. Let's see. Yeah, so we can clear. It's going to pop up. So we decided it was 2.78, negative 2.78, and we're going to put those dots back with the computer there. And what is our distance between them? What is the distance on the number line between the number and its absolute value? From here to here, it's 2.78 units. And then from here to here, it's also 2.78 units, right? So what it's asking us, what's the distance between the two numbers? So the distance is, how would you figure that out? You would add, right? You'd add 2.78 plus 2.78. You add them up and you get 5.56. The distance between the number negative 2.78 and its absolute value of 2.78 is 5.56. Okay, you get to try one of these questions and let's see how you do. Okay, welcome back. Now let's focus on a little bit of higher order thinking. So Olivia finds the absolute value of negative 5.3. She found the absolute value of negative 5.3. We know that's 5.3. And then she found the opposite of her answer. Ben found the opposite of negative 5.3, and then he found the absolute value of his answer. Whose final value is greater? That's going to mess with your mind, isn't it? Why don't you pause the video and see if you can figure it out? Okay, and then we will do it together. So here's Olivia. She found the absolute value of negative 5.3. What's the absolute value of negative 5.3? I hope you say positive 5.3. Yes. And then she found the opposite of her answer. What's the opposite of 5.3? The opposite of 5.3 is negative 5.3. So that's Olivia's answer. Now let's go through Ben's answer. So Ben found the opposite of negative 5.3. What's the opposite of negative 5.3? Positive 5.3, correct. And then he found the absolute value of positive 5.3, which is 5.3. So whose number is bigger, is greater? Ben. Ben's answer is the greater value. I encourage you to go back and look at that again and see if you can figure out what it's saying, because that's important. Okay, let's see what the next one is. Two students are playing a math game. The object of the game is to make the least possible number by arranging 3, 5, and 7 inside absolute value bars. The least possible number. So Brad arranges the numbers like this. He put the 7 first, the 5 next, and then he put 0.3. Okay, and he put a negative sign there. What was Brad's mistake? What's his answer going to be? What's the absolute value of negative 75.3? Well, it's positive 75.3. That's the biggest number he can make, right? Brad made the least negative number that could be made, but he forgot that absolute value makes the number positive. So what is the least possible number that can be made? Did you say put the 3 first, then the 5, and then the 7? Negative 35.7. The absolute value of that is going to be positive 35.7. Okay, give one of these a try. See you back in a moment. Okay, welcome back. We are now going to talk about Google Classroom. That is where your homework will be. And I will say adios, amigos. See you later. Goodbye. Have a good day. Have a good day. Really, really have a good day. You ready? Should I say goodbye? Okay. Are you sure? Okay. Bye. Have a good day.